All right. Good morning, everybody. So I'm just going to go over a few of the questions from the Slope Intercept word problem worksheet. So we have question 1, which says that suppose the water level of a lake is 35 feet, and that is receding at a rate of 1.5 feet per day. And it says write an equation for the water level, L, after D days. Okay, so these are all slope intercept form, right? We know that slope intercept form is y equals mx plus b, whereas b would be like your starting point, and m would be, like the changing, I guess, like the number that's changing. It's more dependent on the other variable. So b is going to be our starting point. And then m, our slope, is going to be like our changing variable. So looking at this question, suppose that the water level of a lake is 35 feet. That's not changing, all right? That's just, we're starting at 35 feet. So which tells me, let's just start writing our equation and start jotting down notes with what we know, okay? So we know that we're going to be using a slope intercept form, so I'm going to have y equals some number here plus b. We just said that 35 feet, that's our starting point. So rather than putting a b, I'm just going to put 35. Now, our changing variable is this 1.5 feet, and we know that's changing because it says 1.5 feet per day. So depending on however many days, we just multiply 1.5 times that number, and then that'll tell us, how much it's receding by. Now, one change, though, that we're going to have to make than like normal. When it says receding, all right, when something's receding, that's going to go up or down. So when you have something receding, it's going to be going down. So rather than putting a 1.5 number, we're going to have to put a negative 1.5. All right. So now we have our equation. It then says graph the equation. All right, so we can just put this in our calculator. We're going to go to y equals, type it in, and we'll press second graph. So I'm going to go y equals. I'm going to type in negative, not minus, 1.5 x plus 35. You can graph it. Oh, I don't see it. So if you don't see it, you just press zoom, 0. We can see. Now, because the water level is receding, we would expect for it to be going down, right? Because every single day, more and more water is leaving. I know on Friday, I just said, just sketch what it looks like. Today, I'm going to do like an accurate graph. I'm not going to just sketch what it looks like. So in order to do that, I'm going to have to go to second graph and bring up a table of values. And I'm just going to write down a couple points. So I'm going to write 0, 35, which is, right here and right here. And then another one I could do would be maybe like when y is 0. I don't see that, but I could do maybe 20 and 5. So I'll do 0, 35, and then I'll do 20, 5. I'm going to write down those 2 points. So we had the 2 points we had 0, 35, And then the other one was 20 comma 5. Remember, this is our x and that's our y. This is our x, that's our y. This is our x-axis, this is our y-axis. Now, we know, that this is like 1, 2, 3, 4, 5, 6, 7, 8, 9. The numbers that we have, 0, 35, way bigger than 9. So we're going to have to make some adjustments, all right? We don't have to go by ones. We can, skip. So we can say maybe that we could go by fives. So we could say that this is 5, this is 10, this is 15, this is 20, this is 25, this is 30, and this is 35. And then over here, we would do the same thing. We could say that this right here is 5, 10, 15, 20, 25, 30, 35. All right? All right, let's graph our first point. So 0, 35 is going to be right here. All right, I'll even label it. That's right there is 0, 35. The other point would be 20, 5. You can see that that point is right there. Then, once you have your 2 points, all you'd have to do is take out a straight edge and draw a straight line connecting them. Done. So it then says, in how many days will the water level be 20 feet? All right, so again, x, in this case, represents, so this right here is going to represent, actually, let me just go to the table. So this right here is feet. All right. We know that this is, x is our days. And we know that because when we did the equation, we did negative 1.5 x plus 35. So it's receding at a rate of 1.5 feet per day. Okay? And the question says, after how many days, like this is tracking like the water level after a certain number of days. So y is the number of days. So all you have to do, we can see it on the graph. All we have to do is just go to, if the y-axis is feet, we just go to 20, which would be right here. And then you could just go over. You could be like, okay, well, let me see. Go to 20, it's right there, okay. And then you could just go down and see that after 20 feet, it's 10 days. So your answer would be 10. You could also just bring up your table and you're going to go to 20 feet on the y and you're going to be like, okay, well, what number is that? Oh, I see. It's 10. All right. So you have different ways you could do it. Do one more question. It says, an attorney charges a fixed fee on $250 for an initial meeting. So let me just highlight important things here. $250 for an initial meeting. So that number is not changing. All right, that's just your fixed fee. It even says right here, fixed fee. And then it charges $150 per hour for all hours worked after that. So again, we're using our slope intercept form, y equals mx plus b. And then then we just got to dump in the numbers where we think it's most appropriate. All right. Question 6a says, write an equation in slope intercept form to represent the situation. As discussed earlier, m is our changing variable, and the b is like our fix, our starting point. So for using that, well, we just see that $150 is the changing, because that's per hour. And then we have our fixed fee of $250. Then says 6b says graph the equation. Go back to our calculator. Type in y equals, it was it 150? Yeah. 150x plus 250. Enter. Well, not enter, but we're going to press graph. Oh, cannot see it. I don't know what I'm looking at, so I'm going to press zoom, 0. Now we get an idea for what it looks like. Again, we're not going to sketch it. We're going to do an accurate graph this time. So what I'm going to do is I'm going to press second graph and bring up my table of values, and I'm going to kind of just write down a couple points. So I'm going to do, first one I'll do is 0, 250. And then the other one I can do is maybe like 5 and like 1,000. So I'll do 0, 250 and 5 and 1,000. All right. Somewhere over here, I'm just going to write 0 to 50, and then 5 and 1,000. So these are pretty big numbers. So we're going to have to adjust our x and y to reflect that. So you got to think like, all right, well, what intervals could I go by to make sure that we could graph those points? So, I mean, you could do whatever you want. I mean, I might go like with 200s. So I'll say this will be 200. This is 400. This right here would be 600. This right here would be 800. And this right here would be 1,000. Now, the x-axis, though, look at our x numbers. So this is our x, this is our y. This just goes from 0 to 5. So for the x-axis, I would go by different numbers. I would just go like 1, 2, 3, 4, 5. And then we're just going to graph our points. So when x is 0, it says y is 250. So I'm going to put a dot where I think 250 is, which would be maybe like right around there. And we're just estimating, all right? The next point is 5, 1,000. So 1, 2, so this is 1, 2, 3, 4, 5. Then it goes up to 1,000. I'm going to put a dot right there. I'm just going to label these points. So 5, 1,000. And we had 0, 250. And then just like before, we're going to take our straight edge and we're going to draw a straight line connecting these 2 points. And there's our line. Then says, question 6c says, find the total cost for a meeting and 6 hours of work. All right, so now they want to know, after 6 hours of work. So I'll add another one. So this is going to be 1,200. This will be 1,400. And then and this is 6 right here. We can like look at it, we can estimate. Like, so 6, if I take a line just like I did before, here's 6 right here. I could go straight up, I hit the line, and I could just go straight across. So it looks like it's a bit below 1200, but we're not sure. We can also just go to our calculator and look at our table of values. And I'm going to go to where x is 6. Oh, and I see it. So after 6 hours, it's 1,150. So find the total cost of the meeting and 6 hours of work. It would be 1,150. That's it.